welcome back to my channel where I break down sciencey stuff in everyday words. Today we are trying to find answer to an interesting question. Can the super high pressure in deep sea change how water gets into things made from composites? Stick around to find out what this means for stuff like boats, submersibles and cool things. Okay, so imagine you have this awesome material called composite. It used to make things strong and light, like boat hulls, submersibles, or even parts of aeroplanes. But there's a problem. Water can sneak in and mess things up, making them weaker and not last as long. So we are here to figure out if the super deep water pressure can change how water gets into these composites. With this backdrop in mind, researchers have turned their attention to the effect of hydrostatic pressure on composite water uptake. Let's delve into some of the key studies that have tackled this intriguing question. Fried in 1967 was one of the early researchers to explore pressure effects on composites. His work revealed a distinction between low and high void composites when subjected to different pressures. Jockeys and colleagues in 1997 conducted a study on a flat composite panel to examine the impact of a 10 megapascal pressure on water absorption. They reported that the effect of pressure on water absorption was surprisingly negligible for the type of composite they have used. As we dive deeper, it becomes clear that the results from different studies vary. Some authors have reported minor increase in moisture absorption, while others noted no effect or even decrease in absorption. Gao and Weitzman went a step further, observing a lower weight gain in certain composite samples under specific pressure conditions. This goes on, and as you can imagine, it's highly variable depending on the type of composite, manufacturing technique used to produce it, and environment it is exposed to. Now let's look into the potential mechanisms driving these varying results. Scientists have proposed different theories on potential mechanisms. However, one can divide them into two broad competing mechanisms that might explain the pressure-water uptake relationship. The first one involves the concept of a free volume effect. Essentially, as compressive strain occurs under pressure, the available space for water to enter is limited. This reduction in free volume could potentially restrict water ingress. It is like squeezing a sponge. When you press on it, there is less room for water to get in, so pressure could mean less water in the material. The second mechanism centers around an increase in chemical potential with rising pressure. This elevated chemical potential could intensify the driving force for water to penetrate the composite material. Now let's talk about a specific set of results from specimens taken from filament wound cylinders, which I believe was the process used in manufacturing central part of the Titan submersible. Davies and colleagues in 1997 uncovered some strong pressure effects in these cases. This could be attributed to the relatively high void content often found in filament wound tubes. Voids, as I explained before, have a role to play in moisture pickup. Harper and colleagues in 1997 and later on in Thomason in 1995 have demonstrated this influence. However, the question remains, do free water in voids impact material properties? So for this, I would go and look at some recent results. So iframers reported results of short beam shear test and 4-point flexural strength tests. It was found that water ingress does have significant influence on the strength to different failure modes. Despite double the water intake in a composite with voids under pressure, the residual properties remained identical, as you can see in these graphs. This finding suggests that while more water entered the material, the overall impact on the material performance was minimal. And this story continues if you go and look at other research papers. So as we wrap up our exploration of the influence of hydrostatic pressure on composite water uptake, it's clear that this is a complex topic with varied research findings and competing mechanisms. The interaction between hydrostatic pressure and composite materials continue to be an area of active investigation. From OceanGate's tragedy perspective, are all the factors discussed above considered that need to be investigated, and for any future use of composite need specific testing to cover critical issues discussed in this video. That's all for today's video. In the next part, I will be discussing about the effect of deep sea pressure on composite mechanics And if you found this topic as intriguing as I did, then don't forget to hit the like button and subscribe for more thought-provoking content on material science and computational modeling. Thanks for joining me, and until next time, keep exploring the world of science and innovation.